So just now we introduced the how to determine the amount of iron in the solution. The first way is called gravimetric analysis. Using a known solution to add the unknown solution and to get the solid product of the unknown solution. And then when we can weigh the precipitation from from its weight, we can calculate the mass of unknown solution. This is the first way. The second way is called titrations. So titrations means we can use one known solution to titrate the unknown solution. When the reaction is complete, so the concentration MA times VA equal MB VB. And for example, for acid and the base, we can use an acid-base reaction to determine to do the titration. So usually we need to add indicate to the solution. When the reaction is complete, the color of indicate will change. Will change from colorless to light purple. So this means the reaction is complete. Yeah.
What indicator do you use?
Oh, indicator means there are many different kind of indicators. Indicators. When for example, if here is base, if here is base, here is acid, here is acid. So the indicate when it is acid, in acid it's colorless. But when the solution changes from acid to base, the color of the indicate will change. Yeah, it depends on the reaction. You can select different indicates. But for some reaction, for example, this reaction, we don't need add the indicates. For the acid-base reaction, usually we add indicates. But for this, for example, redox reactions, we know this is the color of this product, the reactant, and the product is difficult. It's difficult. This is red. This is like a yellow. This is yellow. So after the reaction finish, the color will change from red to yellow. So in this redox reactions, we don't need to add indicates. Okay. But because this is colorless, so in this reaction we need to add indicate. Otherwise, we don't know when it arrives when it is complete. Yeah. Okay, now question. So what volume of 1.42 m sodium hydroxide solution is required to titrate 25 milliliter of 4.5 m H2SO for solution? So in this case, we can say this is base, this is acid. So this is the acid-base reaction, right? Neutralization reaction. So firstly, we need to write the chemical equation, and then we can use like this MA VA equal MB VB. Gustav.
Yeah, but many different. Guys, stop looking. Cheating is going to stop me. Number 2, B. Is it here? Yes. I'm sorry, go ahead. No, I have something already. Yes.
Okay.
No, I have already solved it.
Okay. Next.
After this, you have to explain. No, I don't need to explain. Yeah, they're supposed to be sharp, Joanne.
Look at it. Look at it.
So now we know the volume and the concentration of acid, right? We know the concentration base. We calculate the volume. MAV A equal MBV, it means the ratio is 1 to 1, but now it's not 1 to 1. What's the ratio of acid and base?
What's the what?
Ratio of the acid and the base to base, acid to base, 1 to 2, right?
Yes.
So here a little different.
Okay. This is the salt and water. Make sure I write the aqua solution first, then water. I don't know. I just feel like, but that looks off. I don't know. Look, it's like putting the solid in the last part. Usually the solid is first, and then the other thing is more.
So here, because if here is 1 to 1, right? So maybe you can use this equation. But now it's 1 to 2. 1 to 2 is, yeah. So the
So it's like 1.
more of the more number of acid is just half, right? So this is 2 times of this. So this guy should equal, yeah. So we are how to say the ratio is 1 to 2.
What's the question?
Not the ratio. So this is 2 times of this guy, right?
Yeah.
Now this is, so this number should be 2 times of this guy.
Multiply by 2. MBV times 2. Yeah, multiply by 2.
This way. It's correct or not?
That's not what you said, it's correct. I think it's correct.
I'm not sure. This is more number of base, right? This is more number of acid.
Yeah.
Which one is large?
The base.
For the base it's 2.
Yeah, base should be 2.
Yeah.
Base is large, right? So here,
Now if you change in acid, Ma times, that should be 2.
Huh? Oh yeah, so it's like you want to balance them, right?
Yeah.
which one is large? It's larger.
MBVB is
Base
one.
is larger, right?
Yeah. So Ma you should
So
change
the
that
2 should be on MAVA for it to kind of like balance.
Yeah.
So it has to be safe. It is.
Yes.
Okay.
Because the
Yeah.
base number is larger.
Oh.
Panic by Morris.
Relax, boy.
Imagine. Hey, Morris. Imagine on the big screen.
But you look. But you Zambia.
You represent us nice.
Relax.
What's happening?
The X is down
I have no
there.
idea.
Madam, look at him. Take it to happen again. Morris. In the world.
Hey, 20, multiply this.
Guys,
Hurry up.
that's 100, 120,
120.
I think.
Ah.
Me, I use my head, I told you. That's
You
120.
want that sheet. Calculate.
4.5 multiplied by 25.
Uh-huh.
112.5. How did I go on to it?
100 what?
112.5.
Times 3 is 225.
Times 2.
Give me the answer. Actual answer.
Okay, sorry.
Eh?
100 is 225.
Okay, I think it's okay now. Yeah,
It's
you
okay.
don't have to give the
Yeah.
answer.
Every single time.
Okay, yeah, thank you.
Welcome.
Yeah.
Do you get the concept? Do you get the concept?
No, it's very close. No.
So basically for this question, you need
You
to
went
write
to
the
secondary school.
chemical equation and then balance it. So in this case, we can say 1 will react to 2. So this is the mole of S base is larger than this guy. So here's the time 2. And then we can get this equation. From this equation, we can get the volume. Okay. Oh. How to how to remove?
No, sir.
Not this one.
Ah, the down one.
Go. That Go, pen.
Mm, which you have? Okay. You also have to. So this is one way you can just use get this equation. But here I can show another way. You don't have to think out which is larger. Like this way. Here 1 more, 2 more, right?
Right.
Okay. And here we know the mole number volume concentration. Okay, just use it this way. Here, 1, 1,
Is it?
2, 2.
That's volume check.
This guy put here. This guy put here.
That's volume check.
Okay, because here's 1 to 2. So here should be also 1 to 2. So use it this way. You can also figure out to get the equation. Okay. So remember, 1 from here, 1 more, 2 more. Okay, just like 1 to 2. And then here, more number, this guy here, put it here, equation. And of course, you move this guy here to move this guy here, and then you can get the volume. Okay, second question. 16.42 milliliter of 0.1327 mKmnO4 solution is needed to oxidize 25 milliliter of acid FeSO4 solution. What is the molarity of the iron solution? And of course, you should write the chemical equation. Okay, the chemical equation like this. So in this case, we can say the volume concentration of this guy, right? And we know the volume of this guy. We need to calculate the concentration of this guy. How to do? So here is a 5, 1. Next one.
It's not me, it's hard.
It's you, why?
He's pointed.
Now he's stand here.
Exactly. I'm in front. I'm in front.
Oh, you move from it.
June, all of you.
So use the same way. See, 5, 1, right? Okay, and how to do?
Five more to one.
Find gravity.
It wasn't me.
See here. 1, 2, right?
Yes.
And the volume concentration. Okay, just write the same thing. Okay, 1, 2. And here is 1, 5, 1, right? Yes, 5. Yes, and 1. Okay.
How about this one?
No, it doesn't matter. You don't need to consider this guy.
So,
Volume concentration of this guy. Volume concentration right here, right?
wait. What's KM? Which one is KM? What's that? Confusion.
Below it puts 25.
Okay. But where is K?
That one. On the wrong side. This one.
It's in K potassium.
But
That's
that's not ionic equation. So
So have been removed.
They cancelled already.
It cancelled.
Ah. What? Okay, so. It's confusing.
25 minutes.
Siapa imagine ada apa ini kira?
Yo, não vai estar panic aí. Isso é demais. I'm confused. Last thing to go back again. Go back to the previous one. Yes. Let me use this one first.
1, 2, no, and then volume concentration. This is more number, right? The volume concentration. This is more number.
But then the confusion in this other question is there is potassium in the question.
Okay, so for example, in here, the question is calculate the volume,
Yes, the
right? And here, the question is also calculate not calculate the concentration. Yeah, now we know, for this guy, we know the volume, right? So it's like 25, right? Yes. And now in time concentration, right? Yeah, like M. Okay, it's okay. X. And now here,
And here,
volume.
with the volume,
Volume here.
16.
Yes. Concentration. Concentration here. And then, yeah. How to get the equation?
So here,
No. Say here. How to get the equation? 1, 2, and here, to here. Okay?
so the other did can't work. What do you get? Yeah, but it's okay. But it's getting,
Yeah.
Yes, so something there is ratios there.
but it's okay.
Ngale mjama ratio chini machine.
Yeah. So here it's 5.
5, yes.
5 over
Yes.
25x,
Yes.
which is
Equal. Yeah.
equal to
1.
over
Okay. And now how to get the x? Okay. Yes. Good. Yeah, explain to others.
okay. So like the previous explanation. The answer is this.
Okay, so yeah, the process like this. We know 5 to 1, right? And this is volume concentration. And then we can get this equation.
Let me.
Funny.
It's okay. Okay. Yeah, thank you. So here 5, 1, and volume concentration. So we can. This is a more number. So 5, 1, and here is more number. We can get this, and finally we can. After we get the equation, we can calculate its concentration. So any question for this? So basically, using this way, from here 5, 1, and is I think it's more easier to. You don't have to think, oh, which one is larger. And for example, sometimes if here is 5 and here is 3, right? So it's more complicated, right? If here is 3, so 5, 3, you just write 5, 3, okay, and then the more, okay. So using this way, it's more easier to write the equation. After we get the equation, we can get the concentration. Okay, homework. So that's all for today.
Oh, yes.
Yeah.